So if we look at this identity, tangent squared x plus 1 times cosine squared x minus 1 equals negative tangent squared x. Since I see tangent squared x plus 1, and that kind of throws up a light bulb in my head, I think Pythagorean identity. Cosine squared x minus 1, you may not just right away think of that. But if we were to take this Pythagorean identity, sine squared plus cosine squared equals 1, and I moved the 1 to the left side and the sine squared to the right side. I took this and moved it over here. I took this and moved it over there. Then I would have cosine squared minus 1 equals negative sine squared. Okay, so this is a form of the Pythagorean identity. It's just, where I see that I can put a negative sine squared. The tangent squared plus 1, that's pretty straightforward. So if I did make those two substitutions.
I thought tangent squared plus 1 was secant.
It is secant. Sorry. The third one is cotangent and secant. So if I take tangent squared x plus 1 equals secant squared, and I would have seen, I guess, the error of my ways if I would have tried to plug in the wrong thing and not got that, then what would I have on the left side if I make those two substitutions? I would have secant squared x times what? Negative sine squared x. Still, that's not tangent squared, or negative tangent squared, but I'm a little closer. What is secant squared x equal to? If we apply the reciprocal identity, it will be 1 over cosine squared. All right, and so if I multiply, I have negative sine squared x over cosine squared x, which is negative tangent squared x. And so that's what I wanted. Very last step, just write down that both sides are equal. So that verifies the identity. Now I'm not saying that's the only way to work it, but that's one way that I know for sure will work. You may want to try to multiply these out, but that may not do anything. So you can try all different types of ways to verify an identity, and a lot of times one way will be easier than the others. All right, let's look at another. Tangent x plus cotangent x equals secant x times cosecant x. Now I don't see any squares anywhere. None of these have squares, so don't even think about the Pythagorean identities to begin with. I see 4 different trig functions, and one side is got a little bit more going on than the other. If you chose the right side, the only thing you could really do is move those both to the denominator, and that wouldn't help you. So let's choose the left side. Now I'm going to, there's really nothing, I can't add tangent and cotangent together, so what I'm going to do is I'm going to rewrite the left side in terms of sine and cosine. If I do that, you see, then I will get 2 fractions. Tangent is sine over cosine, and cotangent is cosine over sine. Alright, so if I have 2 fractions, I can always make 1 fraction by getting the common denominator. That's the product of these 2 denominators. So now, look at the common denominator, look at the denominator of the first fraction. So we don't have a sine of x in the denominator of the first fraction. So say sine of x times whatever's in the numerator. It happens to be a sine of x. So sine of x times sine of x is sine squared x. Plus, this is the plus right here. Look at the common denominator. Look at the denominator of the second fraction. It's sine. So that would leave us with cosine of x. So say cosine of x times the numerator. It just so happens to be cosine of x. Cosine times cosine is cosine squared. So now the numerator looks very familiar. Sine squared x plus cosine squared x. That's a Pythagorean identity. Those have to be equal to 1. Remember the Pythagorean identity, sine squared x plus cosine squared x equals 1. So now I have 1 over cosine x times sine x. Remember, I'm multiplying down here, so what would happen if I moved both of these to the numerator? If you move cosine to the numerator, it becomes secant. If you move sine to the numerator, it becomes cosecant. So I have the same thing on both sides of the equation, and I've verified the identity.